Okay, we're going to be simplifying exponents with our exponent rules. And I'm going to just briefly write the exponent rules at the top corner here. Okay? We know that if we're multiplying two bases that are the same, we can just add the exponents. If we're dividing two bases that are the same, we can subtract the two exponents. And if we have a power of the power, we multiply the two exponents. Okay? So with that information, first off, this is a division question. I like to work at fractions, so I'm going to rewrite this question as a fraction. To me, it will be simpler to look at. So I rewrite this as 6p to the power of 7 divided by 3p to the power of 3. Now when we look at this, we want to break everything up. The number in front of a variable is known as a coefficient. Okay? This would be our coefficient, this would be our variable. We have a coefficient attached to both of the variables. I want you to think of simplifying the coefficients with the other coefficient and the variable with the other variable. What would 6 divided by 3 be? That's it, simply 2. Okay. Now with that being said, how would I simplify these two variables? You know the variable is going to be what variable? It is going to be p. And what do we do with these two exponents? We subtract them. So it'll be 2p to the power of 7 minus 3, which will be 2p to the power of 4. So all of this simplified to that. Okay? Maybe rewriting it will help you make sense of the rules a little more. Let's go to the next example. Oh yeah. Next example, 2a times b cubed times a to the power of 6 times b to the power of 4. It's funny that they wrote this x to represent multiplication, because we know that if two variables are written beside each other, it's assumed that they're multiplied. Okay? And if you didn't know that, you do now. These all mean multiplication. So I'm going to rewrite this again. This may or may not help your clarification, but a squared in brackets times b cubed times again a to the power of 6 times b4. This is the exact same thing as it says up here. But now I know that I'm multiplying all four of these. And because we can multiply in any order, I'm going to put my variables that have the same base beside each other so they're simpler to look at. So I'm going to move the a squared and the a6 beside each other, and the b cubed and the b to the power of 4 beside each other. It'll still be the exact same question like we said before. So I have a squared. All I did was move a to the power of 6 beside it, b cubed, and b to the power of 4. Okay? So one simple move, moving this over here, brought my a's together and my b's. Okay? Now from there, these are the only bases that are the same, so these are the only pairing I can simplify with a multiplication rule. Same with these two b's. I can only simplify this pair together. They can't be simplified with each other because one is a base A and the other is a base B. Okay? So with that being said, if I were to simplify these two, I'll write it on the side. What would this become? This would become a to the power of, yes, that's right, 2 plus 6, which is equal to a to the power of 8. So this is written down as a to the power of 8 multiplied by, and then the other pairing, that's right, b 3 plus 4 is equal to b to the power of 7. So this says b to the power of 7. That should be 7. Can this be simplified any farther? Take a guess. Yes or no? No, why not? They don't have the same base. That's it. The bases are different, so I can't go any farther. I simplified all the a's. There's the only one a left. There's only one b left. We're as simple as we get. Okay, this question is probably the most difficult. So let's try to pay close attention here. This one has quite a few rules. Okay? And since the numerator seems to be very complex, there's a whole set of system up there. And there's even a system on the denominator where they want us to simplify. I'm going to focus on simplifying just the numerator to start. Okay? I'm going to simplify the numerator to start, and then we're going to simplify the denominator and bring them back together. Okay? So I'm actually going to split this question up. You'll see in red, I'm just focusing on simplifying the numerator. So negative 2u v cubed times 8u squared v2. Okay, this is very similar to that AB we had just done. They've written multiplication in here, but we know we could represent multiplication with brackets. I'm going to go about doing that. This will say negative 2u v cubed times 8u squared v squared. Okay? The first thing I want to do is deal with the coefficients. The coefficients being the number negative 2 and 8. Okay? Maybe this is hard for you to see. Technically what this means is each of these are multiplied by each other. You know what? I'll rewrite it just that way. Okay? If you are able to see from here where to go, great. Go from there. But if you're still confused, each of these numbers are multiplied. Anytime we have a coefficient times a variable, it's just a number times a number times a number. So it can be rewritten as negative 2 times u times v cubed times 8 times u squared times v squared. Now this is tedious. There's a lot to this. If you're able to just kind of go from up here and make these connections, I suggest you do, or even here. But the reason I wanted to show you this way is because remember with our rules, associative property, what that means is I can multiply in any order. So I'm going to put all of my coefficients or my constants, my numbers together. I'm going to put my u's beside each other and my v's beside each other so they're simpler to look at. Okay. So it becomes negative 2. What number do I want to move beside negative 2? 8. The next thing I have is a u. What do I want to move beside u? U what? That's right, to the power of 2. And then finally, what are we left with? We're done with this and this, this and this. That's right, v cubed and v squared. Now when we look at this, it might be a little simpler. I know I'm going to put these two together. I'll put these two together and these two together. Negative 2 times 8. Good. What's u times u squared? What is it? U to the power of 3. Why? What is here? There's technically a 1 there. Okay. So when we add those together, it's u to the power of 3. And our v becomes v to the power of 5. We add those exponents. Great. We've just simplified the top. Oops, a little far. Let's simplify the bottom now. 4uv squared squared. Okay. Because this is squared, this entire bracket, it means this bracket has to be multiplied by itself. So I can rewrite it like that, or I can imagine that there's powers of 1s here. Okay, and it's a power of a power. And a power of a power we would multiply. In other words, I bring this 2 in, multiply it by this 2. I bring the 2 in, multiply it by this 1. I bring the 2 in and multiply it by that 1. But maybe that's hard, for you to see. So I'm going to rewrite the bracket out. 4uv squared, 4uv squared. Right? We know that a power just means repeating the base. Now, instead of rewriting it out this way and reorganizing it, I'm going to try to work from here, because I think I've become a little stronger with this. I'm just going to multiply the values that go by each other. So what is 4 by 4? 16. That's right, so that's our 16. What would u to the power of, what power is there? 1 times u to the power of 1 be? u2. We add the two exponents together, right? And finally, v to the power of 2 times v to the power of 2 gives us v4. Great. This is the bottom. This is the top. Let's rewrite from here. So this question now reads 16 or negative 16 u cubed v5 over 16 u squared v4. Okay. So you simplified the top and the bottom. There's still one more step here, the division. Okay, remember the red was on top, the blue we did for the bottom? Same idea. We put our constants together, our coefficients, and each of those variables when we simplify. What is negative 16 divided by 16? Negative 1. So I'm just going to write it in black now. What is u cubed divided by u squared? Yeah, and how did you get that? We subtracted. 3 subtract 2. And what about v5 divided by v4? That's right, it's v to the power of 1. Now, here's a funny question. Do I have to write those 1s in? No. I can just write it as uv. And here's another thing. Do I need to write? It does, you're right. Do I need to multiply? What is negative 1 times these values? Do I need to have this negative 1 here? Maybe this part will confuse you. Technically, I could just multiply the negative 1 times the u, and I get negative uv as my answer. But this is acceptable. This is also acceptable. I'll accept any version of these three here. Okay? So just keep that in mind when going through that.